Article 310.15b16 addresses conductors with a cross-sectional area less than or equal to 500 kcmil. According to the 2002 National Electrical Code, conductors with a cross-sectional area less than or equal to 500 kcmil shall not be used to supply continuous loads in excess of the ratings shown in tables 310.15b16 to 310.15b19. To determine the allowable ampacity of a 500 kcmil conductor, you will need to consult the relevant table in Article 310.15b16, which provides ampacity values based on the conductor's insulation type and the ambient temperature. For example, if the conductor is rated for 75 degrees Celsius and installed in a raceway or cable, the ampacity might be around 380 amps. However, this value is subject to dating factors based on ambient temperature and the number of current carrying conductors in the raceway or cable. If the installation environment has an ambient temperature higher than 30 degrees Celsius, you must apply a temperature correction factor to reduce the allowable ampacity. Similarly, if there are more than 3 current carrying conductors in a raceway or cable, you must apply a dating factor to account for the increased heat generated by the conductors. To use 3 sets of 500 kcmil conductors for a 1200 amp service, several conditions must be met to ensure compliance with the NEC. Firstly, the conductors must be installed in parallel. Parallel connections are permitted under specific conditions outlined in Article 310.10g of the NEC. These conditions are designed to ensure that the paralleled conductors are properly sized and installed to prevent overheating and ensure equal current sharing. Secondly, the total ampacity of the combined conductors must be at least 1200 amps. To determine the total ampacity, you need to consider the ampacity of each 500 kcmil conductor, apply any necessary dating factors, and then sum the ampacities of the 3 sets. For instance, if each 500 kcmil conductor has an ampacity of 430 amps after dating, then the combined ampacity of the 3 sets would be 1290 amps, which exceeds the 1200 amp requirement. Thirdly, the conductors must be terminated in accordance with Article 110.14 of the NEC. Article 110.14 covers the requirements for electrical connections, including the proper use of terminals and splicing devices. When terminating parallel conductors, it's crucial to ensure that each conductor is properly terminated and that the terminals are rated for the size and type of conductor being used. This includes using appropriately sized lugs and connectors that are listed and labeled for the specific application. The terminals must be properly tightened to ensure a secure connection and prevent overheating. Finally, the overcurrent protection must be sized for the ampacity of the conductors. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overloads and short circuits. The size of the overcurrent protection device should not exceed the ampacity of the conductors it is protecting, as specified in Article 240.4 of the NEC. In the case of parallel conductors, the overcurrent protection device should be sized based on the combined ampacity of the parallel conductors. For example, if the combined ampacity of the 3 sets of 500 kcmil conductors is 1290 amps, the overcurrent protection device should not exceed 1290 amps. However, it's important to consider the available standard sizes of overcurrent protection devices and select the next lower standard size if the calculated ampacity does not match a standard size. Always verify the specific requirements of the 2002 NEC and consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. This is especially important for service entrance applications where safety and reliability are paramount. Additional considerations include the type of insulation used for the conductors, the ambient temperature conditions, and the presence of other conductors in the same raceway or cable. These factors can all affect the ampacity of the conductors and must be taken into account when sizing the conductors and overcurrent protection. Also, the physical installation of the conductors should follow best practices to ensure proper heat dissipation and prevent damage to the conductors. This includes using appropriate spacing between conductors, avoiding sharp bends, and protecting the conductors from physical damage. The use of properly sized conduit and fittings is also essential for a safe and reliable installation. Furthermore, it is crucial to maintain accurate records of all calculations and decisions made during the design and installation process. This documentation can be helpful for future maintenance and troubleshooting and can also be used to demonstrate compliance with the NEC to electrical inspectors. Regular inspections and maintenance of the electrical system are also important to ensure its continued safe and reliable operation. This includes checking for loose connections, damaged conductors, and signs of overheating. Any issues identified during inspections should be promptly addressed to prevent potential problems. In summary, when using 3 sets of 500 kcmil conductors for a 1200 amp service, it's essential to follow all applicable requirements of the NEC, including the conditions for parallel connections, the ampacity of the conductors, the termination requirements, and the sizing of the overcurrent protection. By carefully considering these factors and following best practices for installation and maintenance, you can ensure a safe and reliable electrical system. The NEC provides guidelines for ensuring the safe and effective installation of electrical systems. Understanding and adhering to these guidelines is crucial for electrical professionals. When dealing with large conductors such as 500 kcmil, proper planning and execution are paramount. The use of parallel conductors, as permitted by the NEC, requires careful attention to detail to ensure that each conductor carries its share of the load and that the system is adequately protected against overcurrent conditions. The NEC tables, such as those found in Article 310.15b16, provide valuable information on the ampacity of conductors under various conditions. These tables take into account factors such as conductor insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. By consulting these tables and applying the appropriate directing factors, you can determine the allowable ampacity of a conductor and ensure that it is suitable for the intended application. Proper termination of conductors is also essential for a safe and reliable electrical system. Article 110.14 of the NEC provides requirements for electrical connections, including the proper use of terminals and splicing devices. When terminating parallel conductors, it's crucial to use appropriately sized lugs and connectors that are listed and labeled for the specific application. The terminals must be properly tightened to ensure a secure connection and prevent overheating. Overcurrent protection is another critical aspect of electrical system design. Article 240.4 of the NEC specifies the requirements for overcurrent protection devices such as circuit breakers and fuses. These devices are designed to protect conductors from overloads and short circuits and must be sized appropriately for the ampacity of the conductors they are protecting. In the case of parallel conductors, the overcurrent protection device should be sized based on the combined ampacity of the parallel conductors. Regular inspections and maintenance of electrical systems are essential for ensuring their continued safe and reliable operation. This includes checking for loose connections, damaged conductors, and signs of overheating. Any issues identified during inspections should be promptly addressed to prevent potential problems. In conclusion, the safe and effective installation of electrical systems requires a thorough understanding of the NEC and adherence to its requirements. By carefully considering factors such as conductor sizing, ampacity, termination, and overcurrent protection, you can ensure a safe and reliable electrical system that meets the needs of the application. The use of parallel conductors, as permitted by the NEC, can be a viable option for increasing the ampacity of a circuit, but it requires careful attention to detail and adherence to all applicable codes and regulations. Remember to always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. The electrical industry is constantly evolving, and it's important to stay up to date on the latest codes and standards. The NEC is revised every 3 years, and it's essential to be aware of the changes and how they may affect your work. Continuing education and training are also important for electrical professionals to maintain their skills and knowledge. By staying informed and continuously improving your skills, you can ensure that you are providing the best possible service to your clients and contributing to the safety and reliability of the electrical system. When working with electrical systems, safety should always be the top priority. Always follow proper safety procedures and use appropriate personal protective equipment, such as gloves and safety glasses. Never work on energized circuits unless absolutely necessary, and always de-energize the circuit and verify that it is de-energized before beginning work. By following these safety precautions, you can minimize the risk of electrical shock and other injuries. In addition to the technical aspects of electrical work, it's also important to have strong communication and problem-solving skills. Electrical professionals often work as part of a team, and it's essential to be able to communicate effectively with other team members, clients, and inspectors. Problem-solving skills are also crucial for troubleshooting electrical problems and finding solutions that meet the needs of the application. By developing these skills, you can become a more valuable asset to your team and provide better service to your clients. Finally, it's important to take pride in your work and strive for excellence in everything you do. Electrical work is a critical profession that has a direct impact on the safety and well-being of the public. By taking pride in your work and striving for excellence, you can contribute to the safety and reliability of the electrical system and make a positive difference in the lives of others. When planning for electrical services, it's essential to consider not only the current needs but also the potential future needs of the building or facility. This includes anticipating future load growth and providing adequate capacity for new equipment and appliances. By planning for the future, you can avoid costly upgrades and modifications later on and ensure that the electrical system can meet the evolving needs of the building or facility. Another important consideration is energy efficiency. With rising energy costs and increasing concerns about environmental sustainability, it's essential to design electrical systems that are energy efficient and minimize energy waste. This includes using energy-efficient lighting, appliances, and equipment, as well as implementing energy management strategies such as occupancy sensors and programmable thermostats. By designing energy-efficient electrical systems, you can reduce energy consumption, lower operating costs, and contribute to a more sustainable future. In addition to energy efficiency, it's also important to consider the reliability and resilience of the electrical system. This includes providing backup power systems, such as generators or uninterruptible power supplies, to ensure that critical loads can continue to operate during power outages. It also includes designing the electrical system to be resilient to extreme weather events, such as hurricanes and floods. By designing reliable and resilient electrical systems, you can minimize the impact of power outages and ensure that critical operations can continue uninterrupted. When selecting electrical equipment and materials, it's important to choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This ensures that the products have been tested and certified to meet safety standards and are suitable for their intended application. It's also important to choose products that are durable and reliable and will provide long-lasting performance. By selecting high-quality electrical equipment and materials, you can minimize the risk of equipment failures and ensure the long-term reliability of the electrical system. Finally, it's important to maintain accurate records of all electrical work that is performed. This includes documenting the location of electrical panels, circuits, and equipment, as well as the size and type of conductors and overcurrent protection devices. This documentation can be helpful for future maintenance and troubleshooting and can also be used to demonstrate compliance with the NEC to electrical inspectors. By maintaining accurate records, you can ensure that the electrical system is properly documented and that future work can be performed safely and efficiently. When working with electrical systems, it's important to be aware of the potential hazards and to take appropriate precautions to protect yourself and others. Electrical shock is a serious hazard that can cause injury or death. Always de-energize circuits before working on them, and verify that they are de-energized using a voltage tester. Wear appropriate personal protective equipment such as gloves and safety glasses, and avoid working in wet or damp conditions. By following these safety precautions, you can minimize the risk of electrical shock and other injuries. In addition to electrical shock, arc flash is another potential hazard that can occur when working with energized electrical equipment. Arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and even death. To protect yourself from arc flash, it's important to wear appropriate arc-rated personal protective equipment, such as arc-rated clothing, gloves, and face shields. It's also important to follow safe work practices, such as maintaining a safe distance from energized equipment and using insulated tools. By following these precautions, you can minimize the risk of arc flash injuries. Another important safety consideration is proper grounding. Grounding is the process of connecting electrical equipment and systems to the earth to provide a low impedance path for fault currents. Proper grounding helps to prevent electrical shock and other hazards by providing a path for fault currents to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. It is important to ensure that all electrical equipment and systems are properly grounded in accordance with the NEC. In addition to these safety considerations, it's also important to be aware of the potential for fire hazards when working with electrical systems. Overloaded circuits, loose connections, and damaged insulation can all lead to electrical fires. To prevent electrical fires, it's important to ensure that circuits are not overloaded, that connections are tight and secure, and that insulation is in good condition. It's also important to have smoke detectors and fire extinguishers readily available in case of a fire. By following these precautions, you can minimize the risk of electrical fires and protect yourself and others from harm. When working with electrical systems, it's important to be aware of the environmental impact of your work. Electrical equipment and materials can contain hazardous substances such as lead, mercury, and cadmium that can pollute the environment if not disposed of properly. It's important to recycle electrical equipment and materials whenever possible and to dispose of hazardous waste in accordance with applicable regulations. By following these practices, you can minimize the environmental impact of your work and contribute to a more sustainable future. Another important environmental consideration is energy conservation. Electrical systems consume a significant amount of energy, and it's important to design and operate them in a way that minimizes energy waste. This includes using energy-efficient lighting, appliances, and equipment, as well as implementing energy management strategies such as occupancy sensors and programmable thermostats. By conserving energy, you can reduce your carbon footprint and contribute to a cleaner environment. In addition to these environmental considerations, it's also important to be aware of the ethical responsibilities of electrical professionals. Electrical professionals have a responsibility to provide safe, reliable, and cost-effective electrical services to their clients. This includes being honest and transparent in their dealings with clients, providing accurate and unbiased advice, and adhering to all applicable codes and regulations. By upholding these ethical standards, electrical professionals can build trust with their clients and contribute to the integrity of the profession. When working with electrical systems, it's important to stay up to date on the latest technologies and trends. The electrical industry is constantly evolving and new technologies are being developed all the time. By staying informed about these technologies, electrical professionals can provide their clients with the most innovative and efficient electrical solutions. This includes technologies such as smart grids, renewable energy systems, and energy storage systems. By embracing these technologies, electrical professionals can help to create a more sustainable and resilient electrical grid. In addition to these technical skills, it's also important for electrical professionals to have strong business skills. Electrical professionals often run their own businesses or work as part of a larger organization. To be successful in these roles, it's important to have strong business skills such as financial management, marketing, and customer service. By developing these skills, electrical professionals can build successful businesses and provide excellent service to their clients. When working with electrical systems, it's important to have a strong commitment to quality. Electrical work is a critical profession that has a direct impact on the safety and well-being of the public. By committing to quality, electrical professionals can ensure that their work is done correctly and that the electrical systems they design and install are safe and reliable. This includes using high-quality materials, following best practices for installation, and thoroughly testing all electrical systems before they are put into service. In conclusion, the electrical profession is a challenging and rewarding career that requires a combination of technical skills, business skills, and ethical principles. By developing these skills and upholding these principles, electrical professionals can make a positive difference in the lives of others and contribute to a more sustainable and reliable electrical grid.